Hello, welcome back to Cracking the Cryptic. I'm hoping to get this video done before they start drilling today. They've been vicious lately. And this is an absolutely fascinating, brilliantly minimalist puzzle from Andreas V called 24 and What. Just two given digits, almost digitless, like the Sudoku Simon solved the other day. 24 there, or 1 and 7 here. We'll look at the rules in a minute, but do check out, as usual, our Discord, our Patreon, our apps, our merchandise, Sven's SUDOKU PAD. They're all on the links in the description field under the video, and we are very proud of everything there and the way that people engage with us and the kindness of our community. Thank you. It's much appreciated. And thanks to Andreas for sending in this puzzle, where I'm going to read the rules now. So, normal Sudoku rules apply. Digits surrounding a circle must sum to the number in the circle. So these four will add up to 24. Empty circles all represent the same sum, which the solver must find. Right, so all of these other circles, I'm not going to count them. It looks like about 2 dozen. No, maybe not quite that many, maybe 20. They all add up to the same number. So those 4 cells will add up to the same as those 4 and those 4, etc. It's a really interesting rule set. Do give this a try. I have no idea how this is going to work, how difficult it's going to be. So my standard guess would be sort of 25 minutes, but who knows? I have no idea how it works. So, and I don't really know how to think about it, which is interesting. So maybe harder than 25 minutes, but give it a try on the link, on the first link under the video. I'm going to start now. Let's get cracking. Where do we start with this? This is weird. I want to use the rule of 45 in the middle. So I'm sure that you deserve to know the secret, which is that the numbers 1 to 9, which fill every row, column, and box in a Sudoku, add up to 45. So every box adds up to 45. Now, this box contains 4 overlapping quadrants that each add up to whatever the number is in the circle, but its constituents individually add up to 45. Now, if I was to colour the 4 quadrants in, I mean, this probably isn't the best colours, but red, yellow, green, and purple, say. Yeah, I mean, this shows that we'd be counting each of these cells once, each of these twice, and this one 4 times because of the overlaps. So I don't know, let's imagine that we had a 5 in the middle, which is the middlest most number, and a 4, 6 around it. What would this, then we could work out what the total in the circles was. So we'd be counting all of the numbers once each, that's 45. We'd be counting these numbers twice because they're in 2 quadrants, and they add up to 18 more because we've counted them once, so we need to count them once more. We need to count this central cell twice more, and that's now 10. Is that right? I don't see how we're getting an odd number. Have I done this wrong? I think that's right. 45, 63, 73 if I was right here. I count all of those. I'm just checking this. Sorry. I count all of those once. I count these again. 18. And I count this one twice more. Oh, no, I need to count that one 3 times more. There we go. So it's not an odd number. Yes, sorry. I was for some reason thinking that I'd included that in the second count, but no, I need to count 3 times more. Right. 40, 50, 60, 78. 78. Well, that's not divisible by 4, so these are somewhere around 19 and a half as the total. So those aren't the right numbers, but I don't know if that doesn't really help. I was hoping for something more extreme. So what should I be doing? Oh, there's overlaps, aren't they? These yes, this quadrant, this imaginary killer cage overlaps with this one, and they both add to the same number. So those two cells add up to the same as those two, actually, and these two. So those groups of cells all add up to the same thing, which is probably quite small because there's a 1 in it. The same is true for these groups of cells, and they're bigger because of the 7. Oh, right, I'm sorry, I've been so slow to see this. Right, the two of the 4 cages that I need to think about, these imaginary cages, are there. Now, yes, the point about this is that's the total of the yellow cells, that's the total of the blue cells, they add up to the same total. So we can eliminate these 2, and then those 2 have to add up to the same as those 2. And it would be exactly the same if we moved yellow and blue down here with a common yellow and blue bit there that we don't need to show. So my point is, finally I have understood that this cell has to be 6 more than this cell, and this cell has to be 6 more than this to make these 2 by 2s work. So that must be a 9-8 pair. This must be a 2-3 pair. Oh look, we do get 4, 5, 6 in the middle. And I think I've worked out that it can't be 5 in the middle. I'm going to do this maths again, actually. So add them all up once is 45. Actually, let's add all of those 5 once more this time. 15, 16, 23 more. And then let's add this central cell twice more. So if it's 4, that's an 8. 45, 68, 76. Then divide 76 by 4, and we get 19 as the total of the whites. But if that's a 6, I'm adding it twice more. So this 8 becomes a 12. That becomes 80. Oh, then we're getting 20. That does work as well. Right. So the white circles are 19 or 20. And that is 6 or 4. But I don't know which. Now, hang on. But this now adds up to 5 or 7, and that is the same. So this adds up to 5 or 7. Right, if it adds up to 7, there's a 4, 5, 6 triple pointing at this cell. That would be 1, 2, or 3 with 4, 5, 6 there. If it adds up to 5, again that's 1, 2, or 3. Oh, now this can be 2 or 3. Same's true down here, same possibilities. Oh, not on the other side, it adds up to 11 or 13. Ah, bingo, it doesn't add up to 13 anymore, because that's the same as these two, and they can't add up to 13 anymore because of this being 1, 2, or 3 now. Yes, this is perfect. Okay, so that's not a 6, that's a 4. Our total in the whites is 19. We now have established that already. Well, I say already, I think it took a lot longer than it needed to there. These add up to 11, so they don't have a 1 in, do they? This is an 8, 9 pair. 2, 3, 7, 8. Let's just have a look at these. These are from 1, 7, 8, 9. These are from 1, 4, 5, 6. Now, surely there's got to be a 1. Oh, actually, there's got to be a 1 in that segment because there can't be a 1 in any of those cells. Do I know what this is made up of? 1, 9 there would put 4, 5 here. 1, 8 there would put 4, 6 here. 1, 7 there. Oh, no, I don't. Okay, there's lots of possibilities. Ah, look, this. Yes, there's an important rule that I hope I read out, that digits may not repeat around a circle. It does say that. I hope I read it out. Sorry if I didn't. Anyway, it's true. So that is a 2, 3 pair. Oh, bother. I thought we were going to get what these were, but actually they can be 9, 5 or 8, 6 now. Oh, that didn't help. What about this? We have to probably start looking outside columns 4, 5, 6. If that's 5, these add up to 14. That's not very helpful. 8, 1, 9. I don't know what this pair is, do I? Don't think so. Crumbs. Okay, I'm getting stuck again. These add up to 8. 5, 3, or 2, 6. These add up to 11. That adds up to 11. So this pair adds up to 8. That's got to be 7, 1, hasn't it? I don't think there's any other way to do that from these combinations. One of them's got to have a 1 in it, otherwise you'd be up to 11. And therefore the other one's got to be a 7. Yeah, that is right. 7 and 1, they can go in. Right. Right, bingo. So now I've got an 8, 9 pair here. Ooh, these can't have a 7 in. There's got to be a 7 in one of these two. Now, I can take one of these numbers out based on this. If this had been 1, 7. Oh no, maybe I can't. I don't know. Let's not think about it. I've got 1, 8, 9 triple there. Ah, yes, I've got a 1, 8, 9 triple there. So one of these is a 1. So yes, that was probably the obvious thing to do. So these don't have a 1 in. And if it's, I'm going to do it again. If it's 1, 8, they are 6, 4. If it's 1, 9, they are 5, 4. So there's definitely a 4 there. No 4 here. So it's either 1, 9, 4, 5. Then we go 8. I don't know here. Should I know what these two add up to? I don't think so. They're not from 1, 8, 9 or 4. So it's 7 with 2, 3, 5 or 6. No, that's not a 4 now. So down here we've got an 8, 9 pair of 7, 1. Oh, this may not be as open as I've thought. 8, 5 and 2 would need a 4. 9, 6 and 3 at the upper end would need a 1. So that can't be 5 or 6. That must be true here. This can't be 5 or 6. Oh, that's helpful up here. Is that right? The minimum here, 8, 5 and 2, 15, would need a 4 here. The maximum, 9, 6 and 3, 18, would need a 1 here. So this is somewhere between 4 and 1. So now I've got a 2, 3 pair here. So this is 7 with either 5 or 6 over this side. Now, this might get us out of the box and into the 24 cage, imaginary cage. That is either 12 or 13. So these two add up to either 6 or 7. Oh, they don't add up to 6 because this pair would have to add up to 18 and they can't be 2 9s. So these add up to 7. That's a 9, 8 pair. 7 there, 12 here. That's a 7, 5 pair. This is a very clever puzzle. So there's no 5 here. So now that adds up to 10. These add up to 9. Let's take out all the corner marks because we don't need them. This has become a 9. I think, yes, I know what this is now. 5, 14, that's a 5. So we get a 6 here, 8 here. That's all work. This becomes a 9. I have a feeling that this is a 4, but I don't know. 8, 14, 16, 3 is the maximum. 9, oh, well, it's not a 4 then. 9, 15, 19. So 3 is the maximum. Again, that's a 2, 3 pair. These are from 4 and 6. They can't be 5 because 5's up there. Oh yeah, this has become a 5. Oh, look, 6, 4, 7. I can do all these central digits. Right, 12, that's a 2. That's a 3, that's a 3. This one's a 9, that one's an 8. Now all the central box ones work. This is a 2. That's fixed 3 and 2. But there's no white dots connecting above. So these add up to 7. They can't have a 5 in because there's no repeat digits. So it's either 1, 6 or 3, 4. Ah, that means 2, which can't be in these cells, is, well, it's somewhere up there actually. That's not that helpful. 10 there. These two add up to 9, but not with a 4 or a 6. So they're 1, 8 or 2, 7. I have a feeling they won't be 1, 8 for uniqueness. No, hang on. even better than that, I've got an 8 X-wing across those two cells. So those use an 8, those use an 8. That uses up the 8s for rows 1 and 2. So that is a 2-7 pair. That's using up 7. So there's a 7 somewhere in those cells. That's not very exciting. Ah, what about this box? 24 there and 19 here is 43, double counting the central cell. So take that away, we're up to 34 or 35. These two add up to 10 or 11. Oh, that can't be a 2 anymore, because that would be 8 or 9, and they're in those cells. So, well, that was interesting. 2 there. Oh, look, this might get it done. 7, 2, 7, 5. No, it doesn't. Now we've got a 7 here. No, there's various possibilities. 2, 8, 9. I don't know what to do next. How do we get out of these boxes? Maybe we use this. Right, yes, this is either 10 or 11. So this pair adds up to 7 or 8, doesn't it? 10 or 11, no, it adds up to 8 or 9 to make 19. Oh, so easy to make these mistakes. So, well, obviously this adds up to 10 or 11 because it has to be the same as that. So if this is 8 or 9, it can't use 3 or 2. So if it's 8, it's 1, 7. If it's 9, it can't be 1, 8 because there's an 8 there. So if it's 9, it's 4, 5. Now if it's 9, this pair adds up to 10, but can't use the odd digits. Can't be 9, 1 or 3, 7. So it would be 2, 8 or 4, 6. If this is 8, 1, 7 here, then this would add up to 11, but it can't be 9, 2, 5, 6, 3, 8. It can't be 7, 4 because there'd be a 7 there. So that doesn't work. So this, wow, that's brilliant. So this is 9. This is the 4, 5 pair. Has to be. That's right. Wow, that's really clever. So 7 there. This does not have to be 3, 4 anymore. Can't be. This is a 3. That's 3 in the corner, losing its religion. Now, we can't have a 4 on this anymore, so that's a 2, 8 pair. This is a naked single 4. It sees 1, 6, 7 there, 2, 8 there, 9, 5, 3 there. So we've got 1, 6, 7 over here. Ooh, I must be able to work out what this pair adds up to. Those are 14 of the 45 in this box. This lot adds up to 31, which is 2 lots of 19, which is 38, minus the double counted ones. These two add up to 7, and they're not 1, 6. So they're either 3, 4 that way round or 5, 2 that way round. I must be able to do the same here. Oh, and if it was 7, I could do it. 10, 14. Yeah, that's the same sum as here, 14. It is. So these two do add up to 7. Just to do the maths on that. 45 in the box minus the 14 there is 31 here. That's 2 sets of 19, double counting those two cells. They must add up to 7. They are 6 and 1, which doesn't resolve this pair or anything above it. I thought that was going to be more helpful. Yes, it is. I get a 7 here by Sudoku. That becomes a 5 to make the 19 around its thing. 9. Oh, this has been an 8 for ages. No. Yes. And I just haven't done it. Right, 9 there, 2, 8 are resolved there. This is a 3, 9 pair. This becomes a naked 5, which is probably helpful with this last thing. 1, 5. If we put a 3 there, we'd need a 10 here, so that's no good. 10, 15, we need a 4, and that works. Yeah, I think this is working now. This is excellent. 4, 3, 7, 5, 2, 8. We've got a 1, 6, 9 triple down here. That can't be 1, that can't be 9. Yes, these have been resolved by that 3 at least. That's a 9, 8 pair. This is a 4, 3 pair. 186 up here. So what are the possibilities here? Well, this can't be 6, 8. There has to be a 1 in them. 716 would leave this being a 5, which is totally impossible. So this is 718. Sorry, I've written the wrong thing. Totally wrong thing. 718, and this is a 3. Yeah, that works. That's a 6. That's not. Don't know there. 4, 5, 9. We know the 9 goes here. Yes, we can do them all. 4 and 5. 4 fixes 6 and 4 fixes 6 and 1 fixes 8 and 1. Wow, this is such an interesting puzzle. Right, 8 and 9 by Sudoku. 14, that, no, 16, that's a 3, that's a 4. This is going to matter. Oh, it's got a 2 in it because of that 2 and that 2. So there's a 2 in one of those cells. And a 3, in fact, in one of those cells as well. That's a 2, 3 pair. These two add up to 14. They can't be 9, 5 because of that pair looking at that cell. So it's a 6, 8 pair. That's lovely. That's a really nice finish to this. That, in fact, is a 7. There we go. We get a 9 in the column here. That puts 9 over here as well. 9, 6, 8, 2, 3, 7 is the digit for there. That's a 1, 5, 4. And hopefully that's going to sort out all our pairs in the bottom 2 rows. Yeah, it's lovely. That is such an elegant puzzle. Really minimalist, but really clever. I mean, maybe not minimalist in the end, because so many of these white dots are provided that once you know the total, it's very clever. But there's some beautiful steps to finding out the total. Could have been a little quicker about understanding the significance of the difference between that 1 and 7. I wasn't really getting that at all. But it's a really neat puzzle. 24 and what? The answer is 24 and 19. And I have enjoyed that one thoroughly. Very good puzzle from Andreas V. Thank you, as always, for following us on the channel. We are very grateful. My volume is turned up as high as I can possibly manage, I'm afraid. So this is all you get. And I look forward to seeing you on the channel next time. As it is, bye for now.